Question A says, do the ordered pairs below represent a function? One way to represent functions is by drawing their domain and range as separate boxes where we put the inputs, which are the domain, on one side, and then we put the outputs, which is the range, on the other side. The inputs are always the first numbers in each pair. So your inputs here are 3, 4, 4, and 6. That makes the domain 3, 4, and 6. You don't have to list elements twice in a set. So I would just put those numbers here on the left. So the proposed domain is 3, 4, and 6. And the range will be the second coordinates in the pairs. So that's going to be your 5, 7, 8, and 9. We can list those here in our box for the range. And then we'll complete a mapping diagram which shows how each x is related to each y. So this first pair tells us that 3 points to 5. The idea being that if you had a machine, plugging in a 3 on the left would result in a 5 coming out of the machine. The next pair is 4 and 7. So let's point an arrow from 4 to 7, and that says that if you were to put in a 4 on the left, then a 7 could come out. The next one represents a problem in this situation. 4 is related to not just 7, but 8 as well. And the fact that one input is pointing to more than one output automatically means that this is not a true function, because we don't know whether we would get out of the machine a 7 or an 8 if we put a 4 in on the left. There can't be any uncertainty in what each input leads to. And our last arrow should point from 6 to 9. That's the complete mapping diagram. And like I said, this issue here is the problem. We can't have 4 pointing to both 7 and 8, or it isn't a function. So here's an x and y axis that I could use to plot those coordinate pairs. The first number is going to be the x, and the second number is going to be the y. So I need a pair of 3, 5. In order to plot that on the two-dimensional coordinate system, you have to go from the origin to the right 3 units. And then we're going to go up 5 units. That takes us to this point right here, and that is the coordinates 3, 5. We also want to plot 4, 7. So let's go over 4 units. And then we have to go up 7 units. That takes us to here. Another coordinate pair is 4, 8. So we have to go again over 4 units. And then we'll go up 8 units. We have one more pair, 6, 9. So let's go over 6 and then up 9. This is a plot of the relation that was described. Now we can do the vertical line test to determine if it's a function or not. The way the vertical line test goes is you draw a vertical line at any given point, and the vertical line needs to touch one and only one coordinate pair in your relation. If a vertical line touches more than one member of your relation, then the relation fails the vertical line test. So with this vertical line here at x equals 3, there's not a problem there. A vertical line here only touches one point in the relation, and so it doesn't fail the vertical line test yet. However, if we draw a vertical line at x equals 4, then we see a problem. The vertical line at x equals 4 touches two elements of the relation, and therefore, because of that, this relation fails the vertical line test. So the pairs of 3, 5 and 4, 7 and 4, 8 and 6, 9, these pairs do not represent a function. These pairs can be plotted in Desmos as well, simply by copying the coordinate pairs to the fields of Desmos. And we get the same graph that I had drawn by hand here. You could type in x equals 3 in order to see a vertical line at 3. And there we see that the relation passes the vertical line test at that point. However, if we move this vertical line to x equals 4, this is where it fails the vertical line test, because the vertical line touches more than one element of the relation. Let's draw the domain and range for letter B here. So once again, our inputs are going to be the first numbers in the coordinate pairs. So our domain is 1, 2, 3, and 4. Let's put those numbers in the domain box. Our range is going to be the outputs, which are the second numbers in the pairs. So that's going to be 1, 2, 4, and 1. So our range is going to be 1, 2, 4, and we don't have to list the 1 again. So let's put those range elements in their set. And now we'll do the mapping, showing that 1 leads to 1, an input of 2 leads to an output of 2, an input of 3 leads to an output of 4, and an input of 4 will lead to an output of 1. Even though more than one input point to a range element of 1, this is a function still. It's a function because none of the inputs lead to more than one output. We can graph the elements of this relation. If we go over 1 and up 1, that takes us to a point that's in the relation. That is 1, 1. We can now go over 2 and up 2 to get to this point. That's 2, 2. We'll go over 3 and up 4, taking us to this point. And we have to do 4, 1 as well. Okay, now this graph of these points, it actually passes the vertical line test. Because if I draw a vertical line at any given x, the vertical lines will touch one and only one point in the relation. So this passes the vertical line test. This indicates that it is a function. So the coordinate pairs of 1, 1, 2, 2, 3, 4, and 4, 1, this is a function.